Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 6 from the October-November 2021 paper 1, variant 3. This is Pure Mathematics 1 from the Cambridge 9709 exam, and this is paper 1-3. And this is also a question that I've added onto my end of topic worksheet for functions. End of topic worksheet number 5 for my P1 Cambridge collection, and this is the second function the second worksheet on functions. And the first question here, we're told about this diagram showing the graph of y equals f of x. So it's got this kind of weird type of shape. It says on this diagram sketch the graph of the inverse of f of x. Okay, so we don't have in the beginning, part B doesn't tell us, well, we have an equation that looks a bit strange. It's a strange type of reciprocal type of function, but we don't actually need to know the function to sketch the graph of the inverse for any graph, as long as we know what the original graph looks like, because we know that the inverse functions will always be reflections in the line y equals x. Okay, when you are finding the inverse of a function, you always swap the y and the x, so you can think of the inverse function being a reflection in the line y equals x, which is like a a slanted line which goes kind of at 45 degrees to the horizontal and the vertical. Okay, so that's the line y equals x. Now this is going to reflect in that line. Okay, so some people might find it a bit difficult to do this reflection, but basically if you think about this half of the line here, it's going to reflect, and it's going to look something like this. If this reflects in the line, it's going to kind of have this kind of shape here. It's going to go like something like this, that kind of shape. I haven't drawn it so well. Let me try and do it better. It has that same curvature, but on this side. Why? Because you see the x values are negative and the y values are positive. They swap around. Now the x values will be positive and the y values will be negative. Okay, because the y and the x's swap around. So whatever this point is here, you're going to have another point which has the same x value on the positive side and the same y value but on the negative side. Okay, so it's going to look something like this, as I mentioned. And similarly, this is going to be reflected also in this line y equals x. So you're going to have this going something like that. So it's going to go something like this. So it's like, you can think of these two are almost heading towards asymptotes. So these two will also be kind of heading towards asymptotes as well. They were kind of like, they would meet over there, I guess, from the way this looks. So this blue line is a line y equals the inverse of f of x. Reflection in, you can say reflection, you don't have to write this down. Okay, but it's a reflection in the line y equals x. Okay, so that's part A, kind of sketched there. It says it is now given that f of x equals minus x over 4 minus x squared square root, where x is between minus 2 and 2. And we can see here that if x actually equals 2 or minus 2, you're going to have an asymptote. So actually there would be asymptotes here, because you're going to have, when x is 2, you're going to have the square root of 0, which is 0, and if x is minus 2, you also get the square root of 0. So x equals 2 and x equals minus 2 would have been asymptotes. Therefore, y equals minus 2 and y equals plus 2 will also be asymptotes for this inverse function. We can see that. Now, it's asking us to find an expression for the inverse function. Notice it doesn't say find the inverse function, it says find an expression for it, meaning we're not required to write down its domain. If the question said find the inverse function and that was it, without mentioning the expression, then it kind of implies that we should also state its domain. In this case, we just have to find an expression for it. So as I said, we're going to start off with y equals negative x over the square root of 4 minus x squared. And when we are finding the inverse function, the x and y switch around. Now I like to switch them around at this stage so that students don't forget at the end. So I'm going to replace the y with the x, and I'm going to replace the x with the y. So wherever I see x, I'm going to write y in its place. So there's two places here, I've written y in place of x and x in place of y. Then I'm going to try to make y the subject. Once I've made y the subject, I will have the form of the inverse. So first thing I would do is I would square both sides of the equation to get rid of the square root, in which case I'll get x squared is equal to, now u squared minus y is going to become plus y, so y squared over 4 minus y squared. The square root sign will be eliminated here when you square both sides. Now I want to make y the subject, so I have to bring the y's together. So first thing, I have to get rid of the fraction. I'll multiply both sides by 4 minus y squared. So I have x squared times 4 minus y squared equals y squared. Now I can expand the bracket. So I have 4x squared minus x squared y squared equals y squared. Now I'm going to rearrange it so that the y squareds are both on the same side. So I'll have y squared plus x squared y squared, and now I can take y squared as common. So I'll have 1 plus x squared. On this side I've got 4x squared, and now I can divide both sides by 1 plus x squared. So I have 4x squared over 1 plus x squared equals y squared. So y is going to be the square root of all of this, 4x squared over 1 plus x squared. I'm going to write plus or minus here for now, and when I write the inverse function, I'm going to choose which one I need. So here I'm going to write this now, because 4x squared is a perfect square, both of them, I can write this as plus or minus 2x over the square root of 1 plus x squared. Okay, so I've chosen to put the plus or minus up there, 2x over the square root of 1 plus x squared. So now, that is the form of the inverse function. Now, to write the inverse function, I have to decide whether to use a positive or negative form. Okay, now, there's a number of ways of doing this. In this particular question, the easiest way of doing this is actually just to look at the inverse function. As you can see, for both the inverse and the original function, an x output which is positive will result in a y output which is negative, and vice versa. Alright, so any positive x input must result in a negative output for y. Alright, so for the inverse function, therefore, I need to have the negative 2x over the square root of 1 plus x squared. Why? Because this is going to give you a positive output, of course. Alright, because we just choose a positive square root here. I put the plus or minus on top. Okay, and if this is I've written this as a positive square root of 1 plus x squared. If x is positive, this has to become negative, and there has to be a minus here then. And if x is negative, this has to be positive, as we can see from our graph. Alright, alternatively, we could choose a value of x. We can say, for example, when x equals 1, let's see what the original function gives us. We say f1 is going to be negative 1 over, that's going to be 4 minus 1, which is 3 root 3. Okay, we've got to choose a value in this domain, which is 1. If I choose 0, it won't help, because it's going to give us 0, and it won't help us because the inverse function also goes through the same point, so it doesn't really help us there. So now, if this is true, then the inverse function should do the opposite. It should undo the function. So this should give us 1. Now, if I replace inside this function negative 1/3 and a negative 1 over root 3, okay, it should come out as 1. If I put this in the inverse function. So I have negative 2 times negative 1 over root 3. Okay, and then I'm going to put divided by over the square root of 1 plus, and this is going to be negative 1 over root 3 squared, which is going to be 1 over 3. Okay, when I square this, I'm going to get 1 over 3. Alright, so this gives me 2 over root 3 divided by, and this is going to be the square root of 4 over 3. Okay, so this is 2 over root 3 divided by 2 over root 3, which gives me 1, which is what I wanted. Now, if that was a plus here, then that would be a plus here, and I would get -1. Okay, so I know that this minus, having the minus here, is the correct thing to do. If I put a plus here, that would be a plus, this would be negative, this would be negative. Negative divided by positive would give you -1, but we want +1 because that's what we put in originally, so we know we're correct. So this is the correct form of the answer. We can see that in two ways. One, from when we substituted a value inside the original function and we put the output of that into the inverse, it took us back to the original. That's one way. The other way is by looking at the graph, and they gave us the graph and they made us sketch the graph. Any positive x input must result in a negative y output, and vice versa. Any negative x input must give you a positive y output, and that's what this will do. Okay, if I put x as a positive value, this is going to give me a negative answer. If I put x as a negative value, this is going to give me a negative answer. If x is negative, then negative will be positive. So this is the correct output, the correct form. Now, one of the things that one of my students noticed is that if I use this form, for example, if I did the same thing and I put inside here my -1/√3, which was the output that we got when we put -1 or 1 inside the function. We got -1/√3. If I put that in this function, then it kind of does the opposite. It's a bit strange because, if I put -1/√3, basically you have plus or minus the square root of 4 times, and if I put -1/√3, it's going to be 4/3 divided by, and there will be 1 plus, and it's going to be 4/3. Okay, so we'll end up with, basically, this is 1 plus 1/√3. Okay, so you have 4 times 1/3 over 1 plus 4/3. So we'll end up with, this is going to be plus or minus the square root of, this will be 4/3 divided by, that's going to be, how much is that going to be? 7/3? Sorry, that's going to be 1 plus 1/3. What am I doing? Sorry, my bad. Let's do that again. I'm doing it on the side here. Let me do this again. So you have plus or minus the square root of, if I put 1/√3, if I put -1/√3 here, I'll get 4/3. And it'll be divided by, if I put 1/√3 here, it'll be 1 plus 1/3, which is going to be also 4/3. So this is going to give me plus or minus the square root of 1. And in this case, this would give you the correct output. If you put minus √1, and that will give you this will give you the correct output, plus √1. Okay, so using in this form seems to be a problem. Okay, and we should always continue and simplify as much as possible. And so, for take the square root of something that can be square rooted, or take the square root of the top separately and the bottom, write them as separate square roots. As we know, the square root of a over b is the same as the square root of a over the square root of b. If we use it in this form, it seems to cause a problem, right? So if you see that kind of contradiction here, then always go back to the original and see from the graph. We can see, if you have been asked to draw the graph, we can see very clearly that when x is positive, y has to be negative. Okay, and this is what's going to cause that, right? So, and again, if x is positive, there has to be negative out here. And this would actually cause a problem because you're going to have plus or minus and then plus or minus. So always write it in this form. Always simplify as much as you can, and then write your answer, and then use that if you're going to check it algebraically. Okay, so there seems to be an issue when you use this form rather than that form to check. So always simplify as much as possible first, and then check. Okay, that's my advice to you from this finding that we found. If anybody has any more insight into this, that will be welcome. But basically, that's my advice to you here in this type of question. Look at the graph. They gave us a graph to draw. Think about that. Also, simplify as much as possible you can do algebraically before you substitute values in. Alright, so now for part C, it says the function g is defined by g of x equals 2x for x between minus a and a, where a is a constant. State the maximum possible value of a for which f of g can be formed. Now, f of g is a composite function. f of g of x is a composite function. So x has to go into g, and gx has to go into f. You have f of g of x. So the output of g of x has to be able to fit into the input of f of x. So basically, what we can say is that g of x has to have an output such that it satisfies this condition, that the output of g of x has to be able to fit into the domain of f of x. It has to be completely contained within the domain of the function f. So this has to be true. So we can say minus 2 is less than, and g of x is 2x, which is less than 2. If we solve this inequality, divide everything by 2, you get minus 1 is less than x, which is less than 1. So therefore, we know that, g of x has to be, so we can say a, alright, so we can say a, which is going to be, when you have something like this is a, we know a has to equal 1. The maximum possible value for a is 1. Okay, I'm not saying that x can be 1. I'm saying if you put a number here, the biggest number you can put here is 1, and x must be less than 1. Okay, so a is equal to 1. That's the biggest number you can put here. I can't put anything bigger than that. It's everything up to 1. So it's between minus 1 and 1, not including 1. That's what it means. Okay, so the biggest value I can put in this position, in this inequality, is a equals 1. That doesn't mean x can be 1. It means that the biggest number in this inequality can be 1. X can be anything just less than 1, and anything just greater than minus 1. Okay, so that is the answer to part C. Alright, so the output of the inner function must fulfill the domain condition for the inner function. It has to be within the range of values. So the biggest value of a is 1. Then it says, assuming that f of g can be formed, find and simplify an expression for f of g of x. So basically we have to just replace the x. F of g of x means replace the x in function f with what g of x is. So basically it's telling us to take the function f and put instead of it 2x. So we take the function f, we replace the x with 2x, we have 2x over negative square root of 4 minus, we're going to have 2x all squared. And they say simplify. So this is probably just 1 mark, simplifying is the other mark. So to simplify this, we can do this. We have 2x, and we have here the square root of 4 minus 4x squared, okay, which can be simplified further because we can see there's a common factor of 4 in these two. So we can take out that 4 from the denominator. That's going to give us the square root of 4 times 1 minus x squared. And as we know, if we have the square root of a times b under one square root sign, we can write that as the square root of a times the square root of b. So I can write this, don't forget the minus sign, minus 2x over, and this is going to be the square root of 4 times the square root of 1 minus x squared. And the square root of 4 is going to give us 2. So here we're going to end up with negative 2x over 2 times the square root of 1 minus x squared. These cancel out, so you're left with minus x over the square root of 1 minus x squared. Okay, so this would be our f of g of x, negative x over the square root of 1 minus x squared. Okay, so there we have our function. Now we could rationalize the denominator if we wanted to, but if we notice the actual the question itself, it gave us something in a unrationalized form. So I don't think there's any problem with us leaving it in this form. If you wanted to rationalize the denominator, you could do. You could multiply both the numerator and the denominator. So I'll just show that step over here. You have the square root of 1 minus x squared. We could multiply both the numerator and the denominator by the square root of 1 minus x squared. So this will be multiplied by 1 minus x squared square rooted. So you're left with a negative. You have x times, you can say the square root of, you don't put the bracket there because the square root 1 minus x squared over 1 minus x squared. Okay, you could write it like that if you wanted to. Okay, that's rationalizing the denominator. Yeah, it's in this case it's not like a conjugate where you have, for example, the square root of 3 plus 2, you have to multiply it by the square root of 3, root 3 minus 2. It's like the whole thing under the square root, you see. It's not the same as this. Some people will say, oh, why didn't you multiply it by the square root of 1 plus x squared? That would be a question that some people might have asked. Okay, that brings up this little point here. But it's not the same as this. It's not like something's under the square root and something isn't. In this case, or they're under the square root, like added separately. They're the whole of this is under the square root. How do you get rid of the square root? You multiply it by itself. Okay, that will give you 1 minus x squared, and then you multiply the numerator also by the same thing. So that's a little side point here. But if you leave your answer like that, that's fine. Okay, you don't need to do this. Yeah, and that's fine there. Okay, there's no problem. The question gave us something in this form anyway, right at the beginning, like this. So there's no problem with us leaving the answer in this form. Although generally it's better to rationalize the denominator to write things in their simplest forms. So that concludes this question part D of this question number 6 from the October-November 2021 exam. Other questions from this particular paper can be found in the playlist, which you'll find at the end of the video, linked at the top right of this screen. The bottom right of the screen will have a video link to the end of topic worksheet number 10 from my P1 collection for Cambridge. You'll find that at the bottom of the screen here. You can subscribe to my channel. You'll also find a link here to functions, my P1 functions questions in general, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.